Hi, in this video we will talk about median and mode. Median is that value of the variable that divides the whole distribution into two equal parts. Now to go for median, we have three types of data: ungrouped data without frequencies, ungrouped data with frequencies, and grouped data with frequencies. So we start with ungrouped data without frequencies. Here is our previous dataset, and we have 13 locations, and the speed of the car was like this. Now before going for finding out the median of your dataset, one thing you have to do is that you have to rearrange the dataset on which you are trying to find out the median. Median actually works with both in ascending order as well as descending order. In this example, we have the dataset in ascending order. Okay. Here we have n equal to 13, that is odd, and later we will deal with n when it will be even. Okay. We have this formula for finding out the median when n is odd. It is a value corresponding to the n plus 1 by 2th observation. Here n is 13, so 13 plus 1, that is 14 by 2, that is 7th observation, and you get this. That means 40 is the median of this ungrouped data without frequencies. You notice here that on the left hand side of the median there are 6 observations as well as 6 observations on the right hand side. Now we go with ungrouped data without frequencies when n is even. Here n is 12, that is even, so we have the formula for that: n by 2th observation plus the next observation. So n by 2 means 6th observation, that is 30, and the next observation, that is 40. So we have this 30 plus 40 by 2, that is 35. Here also we have the same number of observations on the left hand side as well as on the right hand side of the median. Now we go with ungrouped data with frequencies. We have the speed 10 km per hour, that is 4 times, 20 km per hour 1 time, like that. And to calculate median now, we have to go for cumulative frequency. Now what is cumulative frequency? It is starting with 4, like this, and then you add this 4 to this 1 to get this 5. Then this 5 will be added to this 1 to get 6. This 6 will be added to 2 to get 8, like this. You will notice here one thing, that the final value of the cumulative frequency is always the value of n, because ultimately it is the summation of all the previous frequencies in the dataset, right? Now you go for the formula. The value corresponding to the summation of f by 2th cumulative frequency. Now you know that summation of f is actually n. So it will be n by 2th cumulative frequency, that is 6.5th cumulative frequency. Now you notice here one thing, that 6.5 is missing here, right? So from 6 it is going straight to 8. So in that case you will take the next cumulative frequency for finding out the median. So here this cumulative frequency will be considered, and the value there is 40 here. So we say that the median of this dataset is 40. Here also you notice the same thing. The number of observations on the left hand side of this median is equal to the number of observations on the right hand side of the median. Now we go with grouped data with frequencies. For this we have this formula, that's L plus summation of f by 2 minus c by f suffix m multiplied by h. Now what this L is, it is the lower class limit of the median class. Now what is median class? The class where the n by 2th cumulative frequency falls. Now if you do not find this n by 2th cumulative frequency in your dataset, then you can take the next cumulative frequency to the computed value. Okay. Now here you know that summation of f is actually n, and c is the cumulative frequency of the pre-median class. That means that class which is previous to the median class. And fm is the frequency of the median class, and the h is the width of the median class. Okay. Let's go for an example. Here we have speed, that is the class intervals 0 to 20 5 times, 20 to 40 3 times, 40 to 60 3 times, and 60 to 82 times, right? Now we go for computing the cumulative frequency. First we take this 5, and then we add this 5 with this 3, then we get 8. Then this 8 is added to 3 to get 11, and this 11 is added to 2 to get 13. Now we go for this summation of f, that is actually n, which is 13. So n by 2 is 6.5. 6.5 is missing in this cumulative frequency list. So according to this definition, we will consider the next cumulative frequency, that is 8. So our median class will be 20 to 40. Clear? Now you plug the values in this formula. There is a L which is 20, that is a lower limit of the median class, and the summation of f is n. So summation of f by 2, that is 6.5, this one, minus c. C is the cumulative frequency of the pre-median class. Now this is our median class. So pre-median class is this one. So you have the cumulative frequency as 5. So this 5 is here. And on the lower part, you have f suffix m, which is the frequency of the median class. So the frequency of the median class is 3. So this 3 is here, times h. So h is the width of the median class. So we have the median class width as 20. So we have this 20 here. So 30 is the median of this data set. Here is the property 1, that number of observations below and above the median is same. You have already noticed that. On the left hand side and on the right hand side, you have the same number of observations, right? Next is, median is not affected by extremely large or extremely small values, and also it can handle open-end class intervals. So if you have this kind of data, then your median will be staying here, so that on the left hand side you have 5 observations, on the right hand side you also have 5 observations, as well as if you have this starting value on the left hand side very low or outlier, and on the right hand side you have an extremely large value with an outlier like this, then your median will not be affected. Now the question is, when will you go with median? If your distribution is skewed or asymmetric, then median will be a very good choice for finding out the central value. Take this example. Here you see 100, 110, 120, the gaps are 10 here. And from here you notice one thing, that the gaps are very much increasing. So after 185, it is straight going to 250, then to 400, then 600, then 900. That means this data set is actually skewed. But median doesn't care about the skewness. It finds out the middle position, that is 140, so that on the left hand side you have 6 observations, and the right hand side you also have 6 observations. Now we talk about mode. Mode is the observation, that means the value that has the highest frequency or occurrence in the distribution. Okay. Now mode can be calculated with both ungrouped data and grouped data. Okay. Let's start with ungrouped data. Of course, with frequencies. We have the speed 10 km per hour 4 times, 20 kmph 1 time, 30 kmph 1 time, like that. And you have this mode as 10, because in this whole list 10 is having the highest frequency, that is 4. Now we go with grouped data. You have this formula. Now the L is the lower limit of the modal class. Now what is modal class? Modal class is that class which has the maximum frequency. So we have the lower limit of the modal class as L, and F1 is the frequency of that modal class, F0 is the frequency of the class previous to the modal class, and F2 is the frequency of the class next to the modal class. Okay. And h is your width of the modal class. Let's go with an example. Here you see the class intervals 0 to 20 3 times, 20 to 45 times, 40 to 60 3 times, and 60 to 82 times. Now can you tell me which one is the modal class? Of course the modal class is 20 to 40 because it has the highest frequency 5. Now we go with the formula. This one is L, that is the lower limit of the modal class, plus F1. F1 is the frequency of the modal class, that is 5. So this one is F1, minus F0. That means the frequency of the class previous to the modal class. Now this one is the previous class. So we have 3 here. So this one is F0. And the lower side, it is 2 times F1. So F1 is 5 minus F0. F0 is the frequency of the previous class. And this one is F2, which is the frequency of the next class to the model class, right? And this 20 is h. So you compute this and you will get 30. Now in some text, you can find this formula in a different way, but the meaning is same actually. So M0 L plus, it is written like this, F1 minus F0 by F1 minus F0 plus F1 minus F2 times h. Now in any way you move, you will get the same result. Okay. Now we go with the merits and demerits of mode. First, mode is not affected by extreme values. It can handle open-end classes also. And the most important thing is that those classes may have unequal width, because mode does not care about the width of the non-modal classes. And the demerit side is that it is not rigidly defined, since a dataset may have more than one mode. For example, you see this 10 is having the 4 as a frequency, and this 40 is also having the 4 as frequency. So this is a bimodal distribution. Now one last thing we have to discuss. If your distribution is symmetrical, then your mean, your median and mode will coincide. That means the mode's value, the median's value and the mean's value will be same. And if you have asymmetrical distribution, then you have this relation between mean, median and mode. Mean minus mode equal to 3 times mean minus median. If you know any two of them, then you can compute the third one without applying formula. This much in this discussion, and we will meet in the next video. Take care.